Incompressible Bernoulli. Question number 2. Water flows through a horizontal pipe at a velocity of 50 foot per second, owing to the pipe gradually expanding to a larger size. The velocity decreases to 35 foot per second. What is the difference between the pressures at 2 points, one in each size of a pipe? So like question 1, we use the same equation. However, for this one, instead of gradually decreases, it gradually increases. So the figure would be bigger on the other end. Now this will be 1, this will be 2. And our given we have V1, which is 50 foot per second. V2 is equals to 35 foot per second. And we have what else? And that's it. So our required is PB minus PA, or in simple terms, P2 minus P1. Now we don't need to use the flow rate formula for this because the velocity is already given and there's no other things that are needed aside from PB minus PA. Now for the solution, we use the standard Bernoulli's formula, which is P1 plus 1/2 rho V1 squared is equals to P2 plus 1/2 rho V2 squared. Now, knowing that this is an English system and this is density of water, it will be 1.94 slug per cubic foot. We don't know P1, we don't know P2. And we're finding the pressure difference between PB minus PA, or simply P2 minus P1. Now, how do we do that? Well, simply use algebra. P1, transpose it to the other side, it will be negative, which is we are left with P 1/2 PV1 squared is equals to P2 minus P1 plus 1/2 rho V2 squared. Now, like the other question, simply transpose the V2 squared. So this will be 1/2 rho V1 squared minus 1/2 rho V2 squared, which is equals to P2 minus P1, or PB minus PA. Now since 2 and the rho is constant, we can simplify it out. 1/2 rho V1 squared minus V2 squared is equals P2 minus P1. To make it look easier, minus V2 squared is equals to P2 minus P1. Now, substituting in the formula the values, 1.94 slug per cubic foot over 2, and what is V1? 50 foot per second. 50 foot per second squared minus V2, which is 35 foot. 35 foot per second. 35 foot 3 foot per second squared. And this is equals to P2 minus P1. Now, getting the answer. 1.94 over 2 multiplied by 50 squared minus squared minus 35 squared, and we get a value of 1236.75 pound per foot squared. That's the answer. Or 50 foot squared. Cross-checking with the reference, we get the same answer.